Hey, Full Nerd fans, I'm Will, and I'm here today with Andrej, who's the Senior VP of AMD and the Chief Software Officer. I'm excited to talk to you today about ROCm, which is something I didn't know a whole lot about before I started doing the research for this interview, and I'm excited to learn a lot more today. Well, welcome to the show, Andrej.
Pleasure to be here, Will.
We're coming up on 10 years of ROCm next year in 2026, which I think is interesting because I get the feeling that a lot of users maybe aren't super familiar with ROCm. So I think it would be useful to kind of start at the beginning and kind of explain what ROCm is and why consumers, why people who just use their computers in the day-to-day should probably care about it, and why it's an interesting topic.
Absolutely. ROCm is an AMD's compute platform. I mean, the question is what that really means. This is a piece of software that allows various applications, most recently a whole lot of the AI applications, large language models, to access the graphics chip. We have originally designed graphics for gaming, for visual effects, but it turns out that graphics is extremely good in parallel programming. It's extremely good in ability to do very complex tasks in a parallel way. So for on any compute application, you do need the type of interface in software that is going to allow that link. ROCm is exactly that link.
So this is when you talk about massively parallel computing, we're talking about general purpose GPU computing, which people call, I think, GPU is the abbreviation you see everywhere, right? What kind of applications do people use this stuff for? I mean, AI, obviously, we talk about a lot, but are there other things as well?
Well, AI is right now the flavor of the day, of course. When we started ROCm, it was more for what we call high performance computing. It was more for kind of a supercomputers, like the most powerful computers on Earth, like Frontier and El Capitan, that are running ROCm for more of the scientific applications, for weather predictions, for very, very complex calculations, where you need a whole lot of parallelism to make these things happen.
Like, how does this fit into the stack of ways that software interfaces with computers? We started with OpenGL and DirectX almost 30 years ago now. We saw OpenCL. NVIDIA started rolling out CUDA. Where does ROCm fit into this whole kind of pile of software?
That's a wonderful question. Well, let me kind of frame it. So if we talk about Microsoft Word, you mentioned DirectX. DirectX is the interface for really using the graphic chip, mainly used for gaming, for definitely your viewers. And when you look at DirectX started creating a portion of it, and it was DirectML, which was a similar type of an interface, but for machine learning. So that would be the Microsoft world. On the other side, we had OpenGL, doing exactly the same thing for graphics, usually for pro graphics, and then OpenCL was something that was created to provide that machine learning kind of compute type of interface. So ROCm replaces OpenCL, and ROCm replaces the DirectML in these systems. So that's that layer of interface that is kind of very equivalent to DirectX for graphics.
So it's a software. It's a low-level software interface for the massively parallel compute resources on your GPUs.
Absolutely. And the reason for that is if you look at parallelism, the standard parallelism that, especially for compute applications, we would originally do on the CPU. And CPU has like parallel threads. But what you have on graphics, you don't only have parallel threads, you have actually access to parallel data at the same time. And that's what brings this very complex transformational matrices in graphics very useful for compute application.
So that's an interesting idea that you have parallel data and parallel compute, because I think that's something people don't understand probably. Why do we not have parallel data on the CPU side? Why do we have that access on the GPU side, and why is that a GPU exclusive thing?
Well, the architecture of these systems is different. On the CPU, we have parallel execution threads, but they work in their own environment. On the GPU, the memory is organized in such a way that all of the compute units, all of the graphics shaders can access the same memory at the same time. And that provides the ability to create these wonderful images that we create with our graphics cards, to have the visual effects, the textures, mapping over it. And that's exactly the same in compute. Just the task is a little bit more different. It's more mathematical. It's more transforming numbers and matrices.
Okay, so a huge amount of data stored in the VRAM on the graphics cards, and ROCm is more complicated than it seems like than the low level APIs, because it also lets you, like you said, you can do everything from supercomputers down to training models on your workstation if you have the right hardware, right?
Correct. The overall computer programming is in general kind of very complicated, and then complexity goes as you are moving from the CPU to the GPU. We have programmed gaming interfaces and graphical interfaces for a very long time. In 10 years is actually not such a good time, such a long time for everybody to learn how to use the compute interfaces, and that's where the challenge is. That's why we are actually trying to move from that layer of ROCm to be a provider of that interface. But then there are higher level languages like Triton that is trying to abstract that, because there is a lot of complexity in directly programming the graphics chip.
So when I write code to run on a ROCm stack, am I writing ROCm code? Am I writing C code? Am I writing Python? Am I writing Java? What am I doing? What languages?
ROCm is originally designed as a C code interface, but you have the layers that enable Python programming. Triton is one of the best layers just above that that enables Python programming on the top of it. Usually, if you are doing something conventional, let's say you are trying to run some AI model today, you would not directly use ROCm. You would use PyTorch, let's say, that would be installed on the top of ROCm. So for many regular applications, you actually don't see ROCm. ROCm is somewhere there doing the work for you. But if you are a hardcore programmer, you would actually go into the details and you would optimize the areas of ROCm.
Okay, so it sits between your software and your hardware and gives you a nice low-level interface that's designed for compute rather than, say, rendering games, stuff like that. That makes a ton of sense. Okay, we talked about this a little bit before, but what kind of stuff are consumers using this for? I mean, obviously, running AI models locally is on the table these days, which is really novel and exciting. But, you know, I remember in the old days I would use OpenCL applications to help me process raw files faster and things like that. Is that kind of stuff? Are people still doing those workloads with this as well?
Again, that would depend on the type of a user. Interestingly enough, for high performance computing has provided the interfaces for Fortran language. So all of the older type scientific programming is vastly accelerated to using this. So that's one extreme. But I think it's very interesting for everybody who maybe some kids today are going to start searching what Fortran really is. It stands for formula translation. So the idea was just to transfer math into computing. But the other type of users are using the large language models and running them on that type of an interface. ROCm would allow you two types of usage in a big computer systems and systems that, let's say, Microsoft is running, or systems where we provide our developer cloud. You would be able to run that on a server system. But we are right now putting ROCm also on our Radeon products, and that allows you to do things locally. So with one of the best examples would be in our Radeon cards, in our Adrenaline driver. Just recently, at the beginning of the year, we have released a module that is a kind of a helping module, chat box that will allow you to find your way to the driver to set up. It's running on ROCm.
Oh, that's neat. So that's on everybody that installed the Ryzen sorry, not the Ryzen Master software.
Adrenaline, if you install
Adrenaline.
Adrenaline AI, so our Radeon software on your desktop or in notebook, you would get that chat box. You will also get the little image generation as well. So you will be able to run all of this locally, and the chatbot itself is running on a preview of ROCm. We haven't released ROCm for Windows yet. Yes, I committed to release that within this year for sure. We have some previews that we have released, but not the kind of official full release. But in the meantime, most of our users didn't really know that they are using ROCm every day.
So what differentiates ROCm from other GPU stacks like CUDA and Intel's offerings and the other stuff that's out there?
Well, I will speak to CUDA because that's, of course, kind of almost a standard established over the years. And ROCm and CUDA are pretty much equivalent. The programming language in ROCm is one, we call it HIP, which is the abbreviation for heterogeneous programming. So the idea is that we allow ability to program on a CPU and GPU at the same time. CUDA does the same. The interface that application uses to write to CUDA is very similar to the interfaces that we have in HIP. We have even created a program called Hipify. So if you and your application are using CUDA and you want to switch to AMD, you can use Hipify, and then your code will be automatically regenerated to use HIP. So pretty much an equivalent type of a software layer.
Okay, and the goal of all of this is that you can build something locally, you can test it locally, and then you can deploy it to whatever kind of big metal hardware you have, whether it's in the cloud or some dedicated machine sitting in the corner of your lab or whatever.
Well, the way I see what we are doing in AMD is really from your notebook or your desktop up to cloud, because the way I see it longer term is I think every engineering student will have an AMD notebook and will have a ROCm system on that, either on Linux or on Windows, and will be able to work on that system, either as a hardcore programmer, so writing the applications for that, or maybe using the higher level framework like PyTorch, and then loading the models from Hugging Face, adjusting these models, training them for their application, and then eventually executing these models using, let's say, the Onyx execution provider again on their system. So they could do all of that locally, but as they are growing in their knowledge and their needs, they can start shifting to the bigger systems. Currently, we provide a developer cloud that gives you the access to the machine, to the MI series cards. So our cards for big server systems, graphics cards again, using the same ROCm. So it's that is a nice transition for somebody who starts from the notebook, maybe goes to a powerful desktop, maybe goes to a server type desktop. So you can put like 8 Radeon cards in your server and get a whole lot of strength out of that, and go eventually to deploy the cluster of systems in a big computer system.
So can we talk about Hipify a little bit, because it's an interesting idea that you can take the code that was written for the other guy's hardware platform, which, like, in a lot of cases it represents a pretty substantial investment for the people who've been writing that code, and then bring it over into your ecosystem. How does it, is it really fire and forget at this point, or is it a, you run your source code through here and it's going to spit out something that is going to require a little bit more work by the hands of the developers?
I can put my marketing hat, but I'm not a marketeer, so I'll just go down the engineering path.
Okay.
It is not a complete fire and forget, simply because the graphics architectures of two systems are not identical.
Okay.
So I would say that about 98% of the code can be very easily converted. You basically run your source code, the calls are kind of readjusted for you. And we do have examples of many customers, actually even some very big like cloud type customers, running their application through it and then running it at performance immediately. But there are a few of the architectural differences. If you end up using that program in CUDA, then you will have to write around that and actually use the advantages that we would have on AMD.
Okay. Can we talk about Zluda or Zluda? I don't know how you say that one.
Zluda, yeah.
Zluda, because this is basically, as I understand it, this is basically a wrapper for compiled CUDA apps to run on ROCm.
Yes.
Is that right?
Yes, there is a difference in, you can imagine a situation where you're writing up an application, you have the source code, and now you're running with CUDA, you want to switch to AMD. That works. And you run Hippify, and you recompile, and you're fine. But the question is, what happens if you actually don't have the source code and still would want to run it on the AMD? So Zluda is a type of layer and application that makes that possible. What they are doing, they are actually taking the code that CUDA creates to the PTX level, which is a very low level language to access our competitor's chip, and basically they do interpretation of that on the AMD. It works. It's not, again, 100% fail safe, and it's not maybe the most performant way to do something like that, but it provides ability, especially if you have something sitting on your computer that's kind of old and you want to run it. Zluda will help you to do that.
Okay. One of the things that I think
Zluda is not the only one. There are quite a few different trials, and I'm really happy that actually engineers out there are finding creative solutions to kind of circumvent the difference in the platform, like a closed platform and the open platform.
I was going to ask you about the open platform because I think that's one of the key differentiators. I've covered open source software for a really long time, and the thing that I've found consistently is that projects have this kind of growth curve where it starts out really low as like one company or one really enthusiastic person is kind of hammering away at it. And then they hit a threshold where the open source software provides some feature or some ability that the commercial products in that space maybe don't offer, or the price gets right or whatever. And you saw this with OBS and Home Assistant and stuff like that, where they then saw just incredible growth until they became the market leader in those spaces. And I assume since ROCm's open source, that's the goal here, right? Is to get this to a point that it takes over the rest of the market.
Yes, absolutely. Well, and I mean, OBS is a phenomenal example of really kind of open source system just taking the market by the storm. But then if you look at there are many examples of the open source that are really adopted from the start. Linux, in general, like an operating system, is a perfect example. We as a company have I think the most important, and the most easy way to say that is we have this idea of the openness and transparency. And we drive that within all the aspects of our work. ROCm is the prime example of that. And the goal would be we want the engineers to understand what is happening in that piece of software, because it's very critical for various optimizations that you are able to understand why we are doing something a certain way, what you are trying to achieve, and then adjust that. So that would be the first thing. The other thing is you can then adapt ROCm to run on even non-AMD products. You can adapt ROCm to run on some older AMD products that we haven't gotten to yet. The next step is engineers out there contributing to ROCm, putting more optimizations, more libraries for their particular need. Today, when somebody creates a model, they very quickly realize that if they had that particular library that accelerates what they do, it would be so much faster. And that library is not available. Well, on ROCm, you can write it and kind of put it into the ROCm system. Of course, that kind of open system requires a whole lot of integration, a whole lot of openness, and we are working very diligently with the system that we call the ROC, which is open at the tip of our releases. So currently we have like this duality. We do release very stable release of ROCm. ROCm 7 just came out with phenomenal increases in performance. We releases of ROCm for our Radeon cards, but we are also putting the tip of our stack on the ROC and allowing a whole lot of contributions to many users.
So it's interesting. Well, okay, there's a lot of stuff to unpack there. First off, you did say it's possible for other vendors to build into ROCm and support their hardware with your software stack. I mean, the dream with software always, and the reason we build all these APIs is so that you can theoretically have one piece of software that you write once and then it runs everywhere. And it seems like as we get into the GPU and this kind of era, that's faded or to evaporated. Like it's gone. That doesn't happen so much anymore. Do you think that's a realistic, like what timescale do you think that could happen on, or if at all?
Well, the AI and the use of compute is growing at such exponential rate that I would be kind of wrong to put any prediction to it. But when I look at how things happen, let's say in the world of Windows, you have a gelling factor. You have Microsoft driving that top layer, and then all the other vendors, all the vendors of hardware, actually conform to the layer, and there are vehicle quality labs that make sure that this really fits into the operating system. In compute world, that doesn't exist. We think that ROCm has a possibility to be that gelling factor for everybody, and the success of AMD in the compute recently, with our success with Microsoft, with our success with Meta, OpenAI, Oracle, AMD is becoming a force in that AI world. And with ability to run something on our desktops and ability to run something on our notebooks equally well. Notebooks with Strix Halo have a huge memory, can run the biggest possible models locally on the system. We think that that's going to be the changing factor, the factor that's going to allow everybody to start slowly adopting that as interface layer that you could write to and really kind of use it for everything.
So when you talk about wins, when you talk about successes there, you're talking about hardware wins, like these giant companies buying data center, equipping their data centers with AMD hardware, which does highlight kind of the problem with this like it's part of the challenge of this infrastructure ecosystem, right? Is it's both hardware and software, and they have to work together.
Well, all these giant companies are actually using ROCm as the software to power all of that. So it's the only difference is that some systems are open to the outside users. Our developer cloud is the similar type of the huge system open to outside users, but a lot of the work they do is either they do internally training and inference for their applications, or you end up seeing the action that our products do through the standard applications, let's say various copilots, chat GPTs and stuff like that.
So, I mean, just to like AMD has a history of successfully doing this in the past, right? If you look at what happened with Mantle and Vulkan, where AMD built Mantle and then handed that off to the Kronos group to flesh out, it became an industry standard across mobile, desktop, all the available spaces for low-level graphics API. So there is history here of doing this in the past.
Yes, and we are very much like, okay, we want to contribute to community. If you look at Mantle, and then what happened after that, it's kind of DX12 and Metal and Vulkan definitely. That's it. They use the principle that we created with Mantle. We are doing that in all aspects of our work, and we think that that transparency and ability to get more of a global minds put together to do something differently is really important. On a completely different front, we are doing that in the area of security, the deepest possible security of our products. We are pioneering the root of trust for the computer systems that is called Calyptra, used very much on the server systems. We have on our CPUs something that is called SMP, which is the basis of the secure virtualization for server systems, and we open source that because we believe that, and somebody can expect it, they can verify that this is truly the best possible version of the security.
But the security experts love open source because it's really hard to vet closed source software, right?
Exactly.
So if we're looking at that open source timeline, right, of where the gradual, the hardcore people building slowly until you reach the inflection point and the adoption graph hits that hockey stick curve. Where do you think we are? Where do you think ROCm is on that timeline today? Do you have a feeling?
Well, I think we have the adoption with let's call it first adopters. I mean that's for the last couple of years, and now we are getting into adoption with power users, and that is giving us this starting point for the adoption going further. I think the other aspect of it is very important. We as providers of these complicated systems also need to find a way to make it approachable, because you've been talking about developers, like hardcore guys. They're going to compile things, but I'm more that would be too much, but I'm really interested in enabling just the basic computer user to start learning about AI, to start learning about machine learning, start experimenting. And that's today very complicated on almost any system. So we are really working to provide ROCm in a very acceptable form to a basic Linux user and to basic Windows user.
One of the interesting things I've seen in reporting on Phoronix and some other places that cover this kind of high power computing more than we do at PCWorld necessarily is there was a lot of talk about the work you all have done making Docker images and improving documentation over the last year or so, and I think that goes a long way toward getting those enthusiasts engaged. Like I know how to install a Docker container, and I can do that on Linux or Windows. But I think that there's a lot of people out there who probably have GPUs that are capable of this, who don't have that expertise. And do you see that as is that a software problem to solve? Is that an education? Is that an infrastructure problem to solve? Where does that land for you?
Well, phenomenal question. It is a little bit of everything, but it's very easy to say, yeah, it's a kind of knowledge problem, so our users don't know how to do it. Well, that's a wrong way of looking at it.
This is universal for everyone, just to be clear, right?
Yeah. The way we are doing it on Linux, because the compute world and world of ROCm started on Linux, so there is this migration point. What we're doing right now, we are looking at various distros, because again, Linux has the appeal to hardcore developers that can actually create the kernel and kind of do something that really works for them. But most of the users would like to go to a certain distribution and just download Linux on their machine. So what we're doing right now, the advanced distributions currently have a version of ROCm with them. By the end of the year, we are going to have a version of ROCm built into Ubuntu distribution. So the idea is everybody who would download Ubuntu Linux would be able to actually get ROCm at that point in time without even thinking about it, without going somewhere else to install it. Similar thing with Red Hat with their Apple for their enterprise systems. Things are slightly different on Windows. It's on Windows you're just simply used to things working. And that's where we are going. It's again, as kind of a gamer, somebody who did these interfaces for games for so many times. I understand that you expect Windows system to have everything for you and you just run certain application. So that's how we are planning to do it on Windows. We have announced a preview of PyTorch running on our Navi 4 and Navi 3 and actually Strix machines as well. But that's a preview. It's going to come to the point that in a simplest possible way, the driver that you install, our Adrenaline driver, will have an ability to have ROCm in it. It's going to be, I think, options. Simply we don't want to burden your system if you're not interested. And then you're also going to be able to go, let's say, on PyTorch webpage, click on a version of PyTorch, and the right version of ROCm and everything magically will be on your machine, and you can go on Hugging Face, play with systems, and or execute things that have Onyx interface.
Very cool. I mean, it's definitely an increase in usability over the which version of Python do I have to have installed and which 50 Anaconda plugins do I have, and getting all that stuff working on Windows is significantly challenging. I love the idea of apt-get install ROCm as well. That sounds pretty good to me. Let's take a couple questions from our Discord. We reach out to folks on the PCWorld Discord. If you're watching the channel, there's a link to it below. You can hang out there. There's a bunch of wonderful nerds talking about computer stuff all the time in there. Our first one is from Cassilis, and they asked, are there any plans to standardize which devices support ROCm? What about APUs? It's a little frustrating right now to have to dig through documentation to find out which GPUs are supported. Even if two cards are based on the same architecture, one may not. And then they kind of went on for a while. But yeah.
Great question. Yes. First of all, what I announced at Computex this year is that going forward, all our devices are going to be supported by ROCm. So if we go in a forward direction, it's very clear. We just have a little bit of catch up, but towards the end of the year, that's going to start with Navi 2 generation and then going forward. Of course, there is always a request. Okay, let's go back in time. Well, that's where the open source comes in. I'm inviting everybody who wants to contribute to getting their Vega 10 working on ROCm to help us to actually start contributing, and we'll help kind of review the code and make sure that it is working well.
Very good. CloudWord has a follow-on for that, which is. What is AMD doing to ensure that there's day one support for AMD users who want to test out new models when they're released?
Yes, so it's similar to day one games. It's there is the only challenge right now is there are probably like 10 new models published every day. While we are currently successfully running and executing thousands and thousands models on the Hugging Face, I think our focus is going to be like top 20 to top something to make sure that they are running on the day one. DeepSeek was running on ROCm on the day one, so it's we put a very focused effort on that, but the world of compute and AI is just becoming too big.
This isn't a user. This is my question, I guess. This is a big initiative. This is a really important initiative to AMD, right?
Yes.
ROCm in general. It's like it's the foundational work for all of the AI and a lot of the desktop compute going forward. How big is the team working on this? You have to have an enormous team if you're doing all the software stuff, all the packaging, all the documentation, everything that goes along with all of this.
Well, the ROCm team is currently actually the size that's equivalent to the graphics team. And we are talking hundreds, if not thousands, of engineers.
Yeah. Let's see. CloudWord asked, does AMD have a clear product lifecycle plan they can share? Current gen products get added, and previous products are losing support for newest PyTorch, like the 7900 XTX. Are you going to start having a more regimented timeline of support so that people can plan around that?
Yes, and when you look at that, the 7900, it's a Radeon product. So while we actually designed ROCm originally on Radeon, it's kind of, I don't know if your users know that ROCm stands for Radeon Open Compute. the prevalence of the machine learning on the big kind of server systems have kind of really shifted the focus of what we do. And we are coming back now to Radeon, because at one point in time we just looked, there is really no need on that kind of a graphics type product. There is a huge need, obviously, and that's where we're seeing a little bit of shifting back and forth. We are readjusting what we can do. It is the plan is all the products will be supported, and 7900 XTX is a new product, so there is a very clear path to support it. It is going to be more of a, there will be a version of PyTorch that is going to be supported on ROCm for a certain product, and you will be able to actually get that from a PyTorch page rather than going into figuring out the very complex matrix. So we are going to take this guesswork out of it, but yeah, you have to accept the fact that the older version of application software may not be supported, but usually they have backwards compatibility built in, so it shouldn't be a problem.
So, but I mean, if I'm buying hardware to support stuff, if I'm buying hardware today, I want to know that it's going to be supported for the applications I use for X number of years. And is that something that AMD is going to start?
Absolutely. You do have the guarantee from AMD that we, I mean, if I go to the gaming world, kind of all the popular games are supported. They're supported, the products, their new versions are supported. I think it's exactly similar with all of the applications. So ROCm is not losing pieces. We are constantly moving ahead. There will be a matrix of the old version of the same application may not be supported, but the new one will definitely be supported. And there is a period of a couple of years that the window that is shifting.
Okay, that sounds great. Cloudward wanted to know about Strix Halo. It looks like Strix Halo is getting prioritized on Windows in mainline ROCm, while the Linux support is in nightly the ROC builds. No other APUs have support for ROCm right now, and they wondered if that's going to change going forward or if that's a hardware limitation.
Well, Strix and Strix Halo both have the support. They are released in this preview, the ROC. There is a set of releases related to our client systems and our desktop systems is coming up, and they will be coming up in Linux and in Windows. You can currently download it and build it from the ROC, which is the tip of the spear of our ROCm development. The other APUs, we are kind of trying to understand how useful that will be. And again, I'm inviting all the developers out there to help us actually to kind of include these other versions of the APUs. Strix Halo is kind of in the forefront simply because of the capability, a huge amount of memory and ability to really execute very, very big models, which is not the same with Strix. So that's why we are a little bit more speaking about Strix Halo, simply because it gives you more opportunities to do something.
You know, I was looking at benchmarks for the RDNA 4 GPUs and GPGPU applications, and was really surprised that first you were outperforming the comparable NVIDIA parts on newer models pretty much across the board on the 9070 XT, which was lovely to see. It's always good to see. We love competition over here. I wonder if you think that ROCm adoption for consumers was impacted by the decision to back away from that high end, from the higher up in the stack than the 9070 XT model for this generation.
That's a product decision, and I would leave discussion on that to Jack, and you had Jason Bant and the other guys. But I think that allowed us to kind of regroup and not kind of dilute our efforts on multiple products at the same time. Maybe that actually also helped us to say, okay, 7900 XTX. Great product. Let's make ROCm support the best for it. Strix Halo, and you kind of heard that from me again about Strix Halo. We are focusing with Strix Halo not that much on Strix, because you can get more with Strix. Hell, and it's a phenomenal product. There are some great notebook products out there, even some little desktop mini computers that blew my mind. I didn't expect it's going to be that good.
Here, Sneaky Software wanted to know, how much longer do gamers have to wait for ROCm to really benefit games?
Oh, okay. Not much. We are working very diligently to start linking ROCm to the graphics interfaces. Some of it will be in conjunction with our work on consoles as well. That's the next era. We have seen the DirectML bringing some of that kind of compute into the gaming, but because DirectML has a number of layers in between, we have seen a tremendous shift in when we use ROCm. The shifts were showing up on various applications. So right now we are preparing that kind of interface between the graphics and the compute world for gaming, and also to allow ROCm to be on the system to do some really interesting things. I really don't want to play a game anymore with NPCs just kind of wandering around or sitting there in a corner. I want them to interact with me. I want to ask the question. So that's what ROCm will enable on these systems.
If I'm a game developer and I want to support this, am I going to be able to tap into existing gaming APIs, or am I going to have to learn a new thing and apply new technologies to my game? Or depends on the application, I guess.
Well, you depends on the application. You will need to run some kind of form of a model on the side. So that really depends on how you're going to apply that. Just assume that you manage to train the model that is going to improve your visual experience, and FSR is something like that. So do you really need to know how to program ROCm? Not really. You actually have the model that is using that, and you're using it to improve image quality. You can use that approach in gaming as well. But remember, I was explaining, there is just this thing. You have a model. Now it would be nice to have the libraries that you can actually optimize. And that's what we are going to allow. So you will be able to look into the first iteration of what you're trying to do. You're going to see that's great. And then if you go down in the ROCm into the guts and create new libraries, you'll get phenomenal results.
I have one last question, and I'm curious. When we're looking at AMD's got two different graphics architectures, right? One for kind of big compute and data centers and supercomputers, and one for consumer GPUs. Is ROCm the bridge between those worlds, or is there still benefit from running one unified architecture across both worlds?
Well, ROCm is a form of a software bridge on the top of it. We did announce the UDNA at one point in time, so we for the sake of speed of development, we actually kind of diverged from one architecture to two architectures, and we are slowly coming back. So, and ROCm will be that interface that is going to abstract that change that we are going to do.
For app developers, cool. Just out of curiosity, does stuff like FSR run on top of ROCm now, or is that those are two different worlds at this point?
It's using some aspects of ROCm for the acceleration of that machine learning portion, but for something like FSR, you really need to be down in the guts of the GPU
as fast as you can possibly run.
So it starts, as I explained, it starts from that level, and then engineers get into the very, very hard optimizations to get this kind of quality out of the system.
Sounds great. Andrej, thank you so much for coming by. As always, you can find more of this at The Full Nerd. Please look at the links below, subscribe to the channel, and there's probably a video somewhere over here, I would guess, that's going to be something awesome to watch next. So check that out, and we'll see you next time. Andrej, thank you so much for coming by. It's great to chat.
Thank you. It was a pleasure.